So in example 3, what we do is use those properties to expand the expression in each of the following statements. So again, we're just getting practice at manipulating expressions so that we can solve equations in the next section. So again, it's just practice. You got to learn the alphabet before you can learn to spell, kind of thing. So we start off with log base 5 of the quantity x over 2. So this is a quotient. We'll use our property that lets us split that apart into the log base 5 of x minus log base 5 of 2, and we're done. There's nothing else I can do with it. There's no inside exponents. There's no inside products. That's our answer. Part B says we have log base 2 of the quantity a, b squared. So a, b squared. Well, that's a product. So let's go ahead and split that apart into log base 2 of a plus log base 2 of b squared. And again, because it's a product, we put a plus between the two terms. And then we can do a little bit further manipulation because we have an inside exponent. We can use our power rule and move that. So we're going to keep the first term the way it is, log base 2 of a. But for the second term, we're going to move the 2 out in front. So it'd be 2 log base 2 of b. And there's our answer. Part C, we have log base 5 of the cubed root of the quantity x squared plus 1. So our first task is to rewrite that cubed root as log base 5 of x squared plus 1 to the 1/3 power. Now we can take that 1/3 and move it out in front, bring it down. So that would be 1/3 log base 5 of the quantity x squared plus 1. Now, unfortunately, with this one, we cannot go any further with it. I recognize that I have an inside exponent, but because there's a plus between this x squared and this plus 1, we can't split it apart any further. We only have rules that deal with a property. We only have properties that deal with products or quotients, not sums or differences. So we can't do anything if there's an inside exponent. So don't touch inside plus or minus. Don't. You can't do anything with them. So it's one of the hard things to learn. Okay, part B says, okay, what if we have the natural log of the square root of AB? A gentle reminder that the natural log has a base of e. It's just a special way of writing it. We're going to follow the same steps. We need to come in and undo that square root and write it as a fractional exponent or rational exponent is what they're called. So the natural log of the quantity AB to the 1/2 power. Now what? Well, we're going to move the 1/2 out in front, and then everything after it would be times it. And because we have a product, we'll split them apart. We'll have the natural log of A plus the natural log of B. Now, if you want, you can distribute it in. You don't have to. Either of these answers are good. So you can either write it as 1/2 times the quantity, or you can distribute the 1/2 times the natural log of A plus 1/2 the natural log of B. It's your call. Doesn't really matter. And then the last one on example 3, I don't have room for. So part B says we have the log of the quantity a to the 3rd all over b to the 4th square root of c. So the log of a to the 3rd times all over the quantity b to the 4th square root of c. Well, let's see what we can do. So because we have an a to the 3rd in the numerator, I'm going to keep it up as a positive term. But the b to the 4th and the c are both coming from the denominator. So I'm going to say minus, then I'm going to do the quantity, log of b to the 4th, and then plus the log of c to the 1/2. Now I'm not quite done with this. I'm going to do some more manipulation with it. Because these two are multiplied together in the denominator, for right now I'm going to write them as a plus. But notice this negative out in front is going to impact both of those. So in our next step, we'll deal with the power rule. That's going to let us bring down those exponents. So log 3 times log of A minus 4 times the log of B, and then minus, because we're going to distribute this negative in, 1/2 the log of C. And that's my final answer. I've expanded it as much as I possibly can. Notice again that when there's no base written, it's a base 10, so all of these are base 10. Okay, now we're going to go the other direction. So we've expanded them. Now our job is to condense them, which is really what we need in the next section. So Example 4. On your handout. So the directions here ask us to use the properties of logarithms to combine in each of the following problems. So for part A, we have log base 2 of A plus log base 2 of B minus 2 log base 2 of C. And you'll get to the point where you don't need to write these in multiple steps. You'll be able to do them in a single pass through. The only thing I'm going to do on this first pass through is move this 2 back inside. So we're going to have log base 2 of A plus log base 2 of B minus log base 2 of C squared. So now we're going to combine them into a single term. We're going to only write the word log base 2 one time, and then we're going to deal with everything after it. Because there's a plus between the first 2 terms, I know that can be rewritten as a product. So A times B. Because this guy has a negative on him, I know that it's a quotient. It's going to go into the denominator. So I'm going to have C squared, and I'm going to put that in parentheses. So it's log base 2 of the quantity AB over C squared. And there's your final answer. For part B, you have 3 log x plus 1/2 log y minus 4 times the log of the quantity x squared plus 1. Notice you have an inside sign, so you can't do anything to that. Well, each of these coefficients are going to come inside as a power. So each of those are going to come in. But I really don't want to write it more than I have to, so I'm going to use log, and then we'll go straight to the inside stuff. So this is going to give me an x cubed because it's a positive term. I know it goes in the numerator. This is going to give me a square root of y. Again, because it's a positive term, I know it goes in the numerator. The next term is going to get moved to the denominator because it has a minus on it. That's the quotient rule. So we'll have an x squared plus 1 to the 4th power. And I'm going to put the whole thing in a set of brackets or parentheses. So it's all said and done, and you condense this back together or combine them. You get the log of the quantity x cubed squared of y over the quantity x squared plus 1 to the 4th. So part C, you have log 16 plus 1/3 log 5 minus log 2. So, and again, in case you haven't caught, anytime it's a positive term, it's going to go to the numerator, and the negative terms will go to the denominator. Let's see if we can do this one just in one passing. So 16 is positive, it's going to go to the numerator. We have a 5, but a 1/3 out in front of it is going to make that the cubed root of 5. The 2 being negative is going to go to the denominator. And there it is. So we have log of 16 cubed root of 5 divided by 2. However, it is a fraction. So that means I can cancel this 16 and the 2 and get an 8 and a 1. So we end up with a log of 8 times the cubed root of 5. And there's your answer. Okay, one more of this manipulation, this practice. And again, the more practice you get here, the better off you will be in the next section when we start solving equations. So for part D, on example 4, we have log of the quantity x squared minus 5x minus 14 minus the log of the quantity x squared minus 4. So we just have 2 of them. It's a difference between the 2 logarithms, so we know we can write it as a quotient. So this would be the log of the quantity x squared minus 5x minus 14 over x squared minus 4. Okay. I'm a little suspicious because that was rather quick to do. So let's factor to make sure nothing can cancel out. So that would be the log of, we're doing x, the factors of 14, subtract to 5 or 7 and 2. So x minus 7 and x plus 2. And in the denominator, x squared minus 4 factors into x minus 2 and x plus 2. And once I have everything factored, I can see that the rational expression can be reduced. So we're going to cancel out those x plus 2's. We end up with basically the log of the quantity x minus 7 over x minus 2. And that's condensing or combining logarithms into a single logarithm. Finally, in example 5, we're going to use the change of base formula. The change of base formula, we're back on the front page, and it basically says the log base A of M is equal to log base A of M. I'm sorry. Let me try that again. Is equal to the log base B, because we're changing the base to a different base, of M over the log of the new base B of A. So what you're going to notice is the big number goes there, the little number goes here. You can use any base you want. We're going to use either base 10 because that's on our calculator, or base E because that's also on the calculator. So again, you use the change of base formula before your calculators were smart enough to know how to change the base on their own. So part A on that problem asks us to use the change of base formula to evaluate log base 3 of 14. And I think the online homework asks for 3 decimal places, so we'll just do decimal places here. So base 3, I don't know what base 3 is. It's not on my calculator, but base 10 is. So I can rewrite this as the log of 14. Again, no base, we know it's a 10, all over the log of 3. Then I simply go to my calculator. Make sure that when you're using your calculator, you close any parenthesis, it automatically opens on you, because sometimes it'll put a parenthesis there. You must close that before you go to the denominator. And what you should end up with is 2.402. So double check on your calculator, make sure. And then I really want you to double check also. I want you to try using the ln key, so the natural log of 14 over the natural log of 3, not 2, 3. And if you do that, you'll get the same exact answer. So it's just proving to you that it doesn't matter what base you go to, because of the properties of those exponents in the logarithms, right? The base doesn't matter. So, and then finally for part B, just to be different and just to show you that you can use all kinds of symbols also. Part B says on number 5, what if we have the log base pi of 20? Remember, the base can be anything as long as it's positive and not equal to 1. So let's use pi. So I'm going to use ln just because it's quicker to write. So I'll take the natural log of 20 and divide it by the natural log of pi. And if I use the pi key on my calculator, I end up with 2.617. And there it is. That's the properties of logarithms. Again, the key here is practice, practice, practice. Get as much practice as you can.